This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. This is Kaushik, and welcome to episode 22. Today I'm going to chat with you about Joshua Bloch's fifth item from his amazing book, Effective Java. Avoid creating unnecessary objects. On the surface, this may seem like the most obvious item of the century, but I think this is a super interesting and nuanced point. Let's dive in a little deeper. Firstly, as an Android developer, do I really have to care about the unnecessary creation of objects? Generally, yes, for two reasons. A, Android is a memory-constrained environment, which means you can't go all gung-ho with your object creation and memory usage. And B, garbage collection. If you create more objects, and this is also those temporary objects that you might throw around here and there, that basically means more garbage collection. It's sort of a linear correlation here. Fewer objects means fewer garbage collection. And garbage collection for us Android users, especially on older devices and APIs, is definitely a bad thing because it means there's going to be more jank in your UI. Because when the garbage collection process runs, everything halts for a split second, which kind of causes the jank. Interestingly, the second point is actually a recommendation from Google's developer docs. Under the heading, yes, avoid creating unnecessary objects, which is exactly the same as our item 5 here from Joshua Bloch. Now, their explanation and reasoning is a little different, and I have a little trouble agreeing completely with everything that's mentioned there in that page. But we've actually discussed some of the nuances of those points in a previous episode. I'll add the links to all the relevant resources in the show notes. I'll actually even add a special Pocket Casts time-stamped link, so you don't have to listen to the whole episode. Okay, so now when Joshua talks about this point, he basically splits the topic into two camps: immutable objects and mutable objects. Let's look at immutable objects first because it's pretty straightforward. If an object is immutable, meaning its value isn't about to change, you can almost always certainly reuse that object. Okay, so what's a common way to reuse objects, especially if they're immutable? If you're listening along carefully to this whole Effective Java series that we've been doing, right in item 1 we talked about such a technique: static factory methods. Now, item 1 mentioned that one of the advantages with static factory methods is that you can reuse existing objects behind a nice and clean API. So if the object was costly to create in the first place, then you could create it once and maybe store it as a reference and just return the exact same object every time someone asks you your factory method for that object. Sometimes even the core Java APIs have static factory variants. For example, if I asked you to just create a Boolean value today in your Java code, how would you do it? And say for some reason you needed a class variant of a Boolean. That is, you can't use a primitive. You know, maybe you're storing it in a list or some other data structure like that where you can't hold primitives. Now, you could new up a Boolean class, that's Boolean with a capital B, and pass the string true or false in quotes as a parameter. No problem there, but if you actually look at the source code, which you should definitely always be doing, Boolean, the class Boolean, has a static factory method already called valueOf, which takes in a string parameter. So this is definitely a better alternative to use than you just newing up and passing the true or false in the constructor as a string parameter. Why? It basically boils down to this point that I was making before. What it actually does, if you look in the source code, is that it actually avoids creating a complete new Boolean object and instead returns a reference to an existing constant Boolean.true or Boolean.false, depending on the string parameter that you passed. Now, if you simply wanted a Boolean class, true or false, then it would actually make even more sense to just use the constant directly. But, you know, maybe if you have a case where your server API is returning back a JSON where you have true or false coming down as a string and you need it to be parsed down to an actual Boolean object in Java, then this is maybe like a case where you could use this technique. The learning here basically is use the static factory method variant for initialization if one's provided by an API. Okay, so if it's immutable, you can almost always reuse, and a good way to do that is using static factory methods. What if the object was mutable? Let's try to think of an example where the object is actually mutable, but we still want to somehow avoid unnecessary creation. Say you have a person class, and inside this person class, you had a method that indicates if a person was a baby boomer. This is an example from the book, by the way. If you don't know who a baby boomer is, it's basically a person who was born between the years 1946 and 1964. Actually, Joshua should update his example and make it is millennial or something to be more fitting with the times. By the way, do you know what the division is for being classified as a millennial? I'll save you the Wikipedia distraction. It's the early 1980s to around the early 2000s. All right, coming back to the example. In order to return the value for this method, that is baby boomer or is millennial, you first have to take the date of birth for this person, which we can presume to be like a date variable inside this person class. Then we actually have to compare this date of birth with the years 1980 and 2000. Now in Java, if you wanted to create two dates for the years 1980 and 2000, you unfortunately can't just simply new up a date using the constructor and pass in the year, month, and day. Well, actually, you can do that, but if you have a look at the source code of Java util date, that method is actually deprecated. And it's never a good idea to use deprecated methods. The correct way is to actually first get hold of a calendar object, and from there get the time, and then associate that with the date. So if you look at the code, it's maybe something like calendar.getInstance, provide a time zone parameter, and on that calendar object, you basically set the year, month, day, minute, second, blah, blah, all the timestamps onto that calendar object. And from that calendar object, it has a method called getTime, which would return back a date. So all this, creating this calendar object is costly. And every time you wanted to find out if a person was a millennial, you'd have to go through this whole process of creating the calendar object and in turn these two dates, 1980 and 2000, and then compare that with your date of birth. There's a lot of unnecessary object creation clearly here. What if you could just create it once and reuse it? Because 1980 and 2000 is basically going to be the same. You're never going to have to change that often. So that's where we come to the second technique, static initializers. Now, this is also actually interesting for the book Effective Java because nowhere else in any other item does he actually explicitly call out static initializers. Now, some people on the web actually mistakenly reinterpret this point to mean, oh, Joshua Bloch suggests using static initializers, but that's actually wrong. He never states this as an item. What he says is if you want to avoid the creation of unnecessary objects, which is this item, then a static initializer is probably a nice technique to go about this. The last point that Joshua makes is with respect to autoboxing. What is autoboxing? It's a technique introduced in Java 1.5 where the compiler basically gets a little intelligent and coerces certain objects to another type. For example, if you write a boolean a is equal to true, that's boolean with a capital B, you would have noticed that the compiler doesn't throw a fit assigning a primitive to a class. And the reason it doesn't is because of this whole autoboxing technique. This is like a special case where the compiler understands what you want and basically just creates the Boolean class object from the primitive. You can mix primitive and boxed primitive types and the compiler essentially will just understand how to construct the class. But there's a certain cost associated with autoboxing, and Joshua gives this fantastic example where autoboxing can essentially wreak havoc in your code. You should actually take a look at the code because it's totally worth it and it's a very interesting example. I'll add a snippet here in the show notes for you lazy ones who don't want to actually go back and open up the book right now. It's a snippet that basically is trying to calculate the sum of all integers. Now, clearly, you can't store the sum of all integers in an integer. So he initializes this long object, that's long with a capital L, and inside this for loop, which runs through all the integers, he keeps adding all the integers. The problem is when he adds the integer to a long, the compiler doesn't throw a fit, but he's actually adding like a primitive integer to a long object. So what the compiler does every single time inside this loop is it constructs a new long object, it auto boxes the two, and then proceeds. This can make your program hideously slow. In fact, he says like if you correct this small mistake, the runtime can go from 43 seconds to just 6.8 seconds, which is like crazy, especially considering that the fix is almost just like a typo. Instead of using like the long object with the capital L, just convert it to a primitive and boom, you get all that efficiency. So the learning here is if you can get away with a primitive, definitely use a primitive and be very careful that your primitive is not getting auto-boxed. Okay, all these points are totally valid in the world of Android, but I want to wind this item down by saying don't really get your knickers in a knot and start re-examining every single use of an object creation. Sometimes people go crazy and start creating object pools so they can conserve the creation of objects. Very rarely do you actually have to resort to such extremes. Even Joshua points this out at the end. If you try to get smart with your object creation strategy, know that you're bringing in more complexity to your code, which is almost always like the worst option. The problems caused by the complexity in your code by trying to reuse is like far, far more insidious and dangerous than just creating more objects. I mean, sure, it might be less performant, but it's far more easier to maintain, to understand, and read, which is like essentially the most important virtue for any good software developer. I hope you enjoyed this item. It's deceptively simple with its definition, but there's a lot to think and ponder about. You can always get in touch with both Don and I with our Twitter handles or with the Twitter handle Fragmented Cast. And the show notes for this item is at fragmentedpodcast/episodes/22. Catch you folks later.